All right. So, yeah, interesting bug came up that I want to see if I can debug it while recording it because um, I have a particular way of debugging that is difficult to explain, much easier probably to demonstrate, but you really want to demonstrate it on a real bug where you really don't know what's going to happen because otherwise it's all very sort of just so and seem like you want to see what the actual process looks like. So this seems like a good candidate for it. And so we'll see how this turns out, but hopefully it'll be a good demonstration of what I mean when I use the term absolute debugging. Um, yeah. So the bug is that in Kelvin 414, so what's on mainnet right now, when you make a commit to base, any commit, it's pretty much instantaneous. I mean, if you do something that makes everything reload, that's going to take some time. But if you make you just add a text file to base, it's pretty much instantaneous. By comparison, in 413, which is the one that's in pre-release and is going to be released in like 2 weeks or so, you make that same commit, you get it takes like a minute-ish, and that's obviously way too long. And so we want to see what could be causing that. Now, I haven't been following the PRs that have been going into 413 that closely, and so that's actually ideal for the kind of debugging that I'm talking about because I don't know what could possibly have changed that. I don't remember any changes to Clay, but maybe there were some in there. Maybe there was changes to the compiler, or I don't know. I know there was changes to like the JSON parsing, but surely there's no JSON involved in this. But like, who knows? And so that's we need to figure out what's happening, and given just that information, I think my claim is that if you're good at debugging and you follow good processes, you should be able to figure it out pretty quick. We'll see how long that actually takes, but I think this is very doable. So the only thing I've done ahead of time, other than find the reproduction, which is just to write a file, is I did reproduce it once, right? So I have a ship here, which is on 414. These are both fake zods. Actually, it's on 415. 414, I'm told, is the same. I could verify that. But, and then I have one here that is a fake neck, and it's on 413. And if you run this here, it happens instantaneously. And if you run it here, it takes a while. So that's getting to this step is obviously a huge part of the problem. But once you get to this step, then you should feel good because it can't take very long to find out what's happening. So we want to get some sense of what's happening at a high level. It means we want to start printing things out and just observing what's happening. But definitely, like I know I have code at the top here, but that's just because my workflow tends to have code at the top. We're not looking at code yet. We're not looking at diffs. We're not looking at any of that. This thing takes a minute or so to run. We should see what it's doing. There's a couple of ways to find out what it's doing. One is to run it under profiling. Another is to turn on some levels of verbosity. This will end up finishing, but I'll just kill it for now. Levels of verbosity. We can do both of these. Levels of verbosity is slightly faster, so I'll just do that while I really should just do both at once. But let's see. If I remember right, it's this. That's the first level of verbosity, which is enough to tell us if we're hitting caches. We can increase that 1 to 2 or 3 and get something more. So now if we, and actually we're going to do this on both ships. Now if we run this, we see this kind of output, which says, well, we read that file. We also needed to goad, so we needed which means that we needed to compile all these apps. But compiling those apps, well, so all these apps for base, all these apps for garden, all these apps for groups. Actually, sorry, that's another difference. This is just a peer that I had lying around. So this peer happens to have actually all these desks in it. This one doesn't even have those desks, which, or at least I believe, which will, you know, it shouldn't be, that shouldn't make it even harder than it is. Anyways, so it does go to everything, but that's it. We're not missing any caches. We're just rebuilding everything. Here, now if we, let's see, let me get this into one of my relatively persistent paste buffers so that, you know, it's not just like whatever I select or control C or whatever, to make it easier to paste that, because I'm going to be using this command a lot and it's going to be dying where you can't necessarily up arrow. So here we can see already we're doing something very different. In fact, to the point where we may not even need to profile at this point, because we can see that, okay, that part happens just like normal. The commit itself happens like normal. We goad. So goad means whenever changes happen, pretty much any change happens, we need to rebuild all of our apps, but that should be really fast because you should be hitting a cache on all of them, or just about all of them. And that's not happening, or at least not happening in the correct way. We're going to want more verbosity. I will start looking at the code just to see what levels of verbosity can give us. In particular, what does this forward make file, what does that imply that we're seeing it for all these things? So we're seeing it, unfortunately, some of the terminal stuff is confusing for this. But so for example, we're seeing like, okay, we're compiling this app, and this app needs this library. Actually, it needs those 3 libraries, and some of those libraries apparently need these libraries. So we're somehow traversing the whole app. So we're missing the top level cache, but there's 2 levels of cache in forward. It's unclear if we're hitting some of the internal ones. So let's see what makefile corresponds to. Let's make sure this is at the tip of develop. Forward make file. There, I guess it's, yeah. Okay. So this happens in build dependency. Build dependency is basically when you try to build a file, we end up in build dependency. Each of these build something arms starts with a preamble that looks more or less like this. So for example, like build tube, which is a kind of conversion, has that same preamble. This preamble handles the caching basically. So in particular, this gain sprig one defers this, so it says only run this if we don't see you in the cache. So the fact that makefile is being printed means that gainsprig, and I'm going to review some of this stuff because it's been a while since I looked at it, means that gainsprig decided to run to run this, which means it believes that it has missed the cache. Let's look at gainsprig, make sure that we remember what that is. So you give it a cache key and what to do if you miss. It looks it up. If it misses, then it runs it. Otherwise, if it hits it, no. So if it misses the cache, then we run it. Otherwise, right, so this is not updating the cache. This is only looking up, right? So otherwise, we usually, sometimes, add us into the stack. The stack should be mostly unrelated to this. We'll see if, we'll come back to it if it turns out to be related. But and then we produce what we received. So if we find it, we produce what we received. We don't kick the next trap. Okay. And just to make sure that we remember how this works, soak vase. So there's all these soak ones saying what kind of thing are you soaking. When you're building a file, the result's going to be a vase, and so we get that result. We just produce it. Okay, so what's supposed to put something in the cache? I guess that's. Oh right, that's the other half of this. So there's gain sprig. So there's this preamble, and then the other part of the pattern is when you get an answer, you put it in the cache there. It used to be that you'd be like, well, you look up and put it in the cache in the same place. This doesn't work for relatively convoluted reasons. So what we actually do is we have this gain leak function, which has the same arguments more or less. So it takes in the cache key, which is the same cache key as here, right? It like our problem would be explained if that cache key was different, but it appears to be the same cache key. This path got shadowed and looks like it was not. And you pass it a function from state to soak state, which is supposed to basically add it to actually both caches, right? Because it should be adding it to your global cache and also your per desk cache. So this is supposed to let's see. Let me get these types up somewhere. I guess it's in lol. Yeah, so the actual cache key, we've been using mist as a kind of cache key, but it's mist is actually a request, not a fully specified cache key. Leak is a fully specified cache key. And so when we're given a mist, we want to turn it into a fully specified cache key. The way you do that is you see what does it depend on by reading that out of your stack. And then so that gives you all of your dependencies, or the cache keys of all of your dependencies. And then you also take the mist, turn it into a pour, which is basically you pin it, right? So mist is like, I want the file at this path. Pour is also I want the file at this path. Okay, so what's the difference? Veil is a good example of the difference. So pours are always going to these top ones, which are in both pour and mist, they're always going to depend on other things, and at the leaves of those trees, we have these two. So everything's either going to reduce to an arch, which is unusual, or a veil. Veil being the most common one, and that's that you just need to validate a file. So take a file that just has a noun in it and turn it into something that matches, say, the Hoon mark or something like that. Make sure that it actually does. And that, in mist, we just refer to a path. We're saying we need to validate this path. That's the command. In pour, which is supposed to sort of pin that, it says, okay, validate that path, but also this cache key should only work if that path has this lobe. So it has this content. Okay. Anyways, all that to say, we've constructed the fully specified cache key that we want to add this in at. Okay, and so then we want to we go ahead and right. Okay, so gain leak does two things actually. Let me revise this again. I'm reading this to remember what all this stuff does, to have even a framework for this. So there are two levels of cache, right? There's the global cache, and then there's the per desk cache. You want to hit the per desk cache when you can, because it's going to be much faster. You can hit the per desk cache based only on a mist. So based only on the request, you can check the per desk cache. The problem is that because, for example, it doesn't have the lobe in the veil, it only works for the current commit. And when you go from one commit to the next, you need to try to preserve as many of these as you can. So the cache key for the per desk cache is a mist. Cache key for the global cache is it's a leak, which is a combination of a pour and a set of dependencies. So it's much more complicated data structure because it has this whole tree. And to generate that tree, you may need to do things, right? So for example, to generate the tree for app hood, what we saw before was, well, you're going to need to generate the tree also for all of its dependencies, right? Because maybe it's only a dependency of drum that's changed, right? So you have to check for drum, helm, kiln, Strandio, some of these other ones, might be even marks and all kinds of things that are implicated in that. So the thing you have to do to check the global cache is you have to parse this file, right? You have to parse it enough that you can see what its dependencies are. Hopefully you don't have to actually build the file, but you do have to parse it. And so when you look at a function like this, you have this initial preamble that's saying basically try to hit the per desk cache. If that works, great. If not, then go ahead and parse it until you get down, and try to determine what its dependencies are. Once you know all of its dependencies, then you can construct a global key, a global cache key, one that's suitable for the global cache, which is a leak. That's the key is called a leak, right? This is the global cache, right? It's a map of leak to soak, basically, to response. Whereas the per desk one is this map of mist to response. And so we say, okay, now we know its dependencies. Now we run gain leak, which says look up in the global cache. If you find the global cache, great. If you don't find the global cache, then you're going to need to actually run this thing. Looks like we don't have a printf right here, but maybe there's one inside a gain leak that we can trigger. So the fact that we're getting to these make files means that we are unexpectedly missing the per desk cache. Now, are we also missing the global cache? That is, we have not yet determined. Let's see if we have printfs already to be able to determine that. We could also potentially just put in some printfs right here. But my guess is gain leak does have a level of verbosity that will tell us the answer to this. So gain leak is supposed to look up in the forward cache, and it will also... So gain sprig looks up in the local cache, but doesn't add anything to the local cache. Gain leak looks up in the in the global cache, and I believe that it will, if it does, if we miss, and so we have to run this next function, we have to find out the answer by computing it, then it should add it to both the global cache and the per desk cache. It's important that you add that to both of them at the same time because we have to ref count these things for garbage collection purposes, or well, ref counting really, but yeah. Okay, so we take the request, and we say, okay, what do we depend on? Well, we can see experimentally the stuff that we've been pushing onto our stack. That's what we depend on. So that's our set of leaks that we depend on. Because that's all the stuff that we had to build to get to this point. Build or pull in from cache to get to this point. And then we convert mist to pour by looking up what that path is, turning to a lobe if necessary. And then we say, okay, now we do some stack management stuff, which we'll review and try to load into our mind if it looks like it's a culprit. Otherwise, we check and see in so spill.nub, we check and see if this is, so this is our ref counting thing, right? We check and see if this is currently a if this item that either is or will soon be in the global cache, is it something that's referred to by the local desk cache? If it is not, then we're going to need to add it to that. But so that's a ref counting thing that we can probably ignore. And then we say, okay, check lookup in cache.nub, which is the global cache. It's a flow, right? Lookup is this leak in there? If it is, then we're going to print something out. And if it is not, we're going to print something else out. So that tells us that we are going to be able to get useful printfs. Let's make sure we understand what's happening here. And remember, I'm looking at this to understand printfs, understand what it's supposed to be doing. I'm not looking for bugs. Okay, so if we do find something in the cache for this, then we are going to possibly add it to the per desk cache. So if it was in the global desk, then we may add it to the per desk cache if it wasn't already there. And if that's the case, then we're also going to need to bump the reference count that's in the global cache. If it was already there, then this is just a straight cache hit and nothing needs to change. There's no increase in references or anything like that. Okay, so then, yeah, so that makes sense. If it's a cache miss, then that means it's not on our global cache. If it's not on our global cache, then we're going to need to run the computation. So we do that. That gives us a result. We add it with a ref count of 1 because we just created we're just about to create a reference to it. Didn't exist before, so that's always going to be 1. And the actual value. And then we say we need to now increase the ref count of all of our dependencies, right? Because those now have, because you can get references into the global cache two different ways. One is the per desk caches might refer to something, which is a sort of root of the global cache, or the global cache items in the global cache might refer to other things that are already in the global cache via its dependencies, right? So app hood depends on Helm, Kiln, and the other one, and so the fact that it refers to those means it should increase the ref counts of those. Anyway, so we do that basically. We go through our dependencies. At trace level 3, we mark that the references changed. And yeah, increment the reference. And that's it. So once we've done that, we're done with this block, and then we say, okay, spilt again means if it wasn't there before, so if it was already there, we're done. If it's not already there, then we want to add it to our set of leaks and also add it to our per desk cache right there. And we print that out with trace 3. So I think we should run through this with trace 3 on, and then we can see what exactly is happening. So I always give people this command, but that 1 is just the first level. There is a 2 and a 3. So let's run it with 3. But first, for a baseline, let's run the normal one with 3. And see if we can understand that. Sorry, 4 didn't actually change anything. So 5. So the output that we see here is that we check and see, okay, so foo.txt changed. So that means that we need to recognize that that's no longer, like that should be freed. And we apparently do that correctly, right? We free this reference, and then we create one that's actually kind of surprising that we recreated it with the same lobe. That's very strange. We will see if we notice anything about that. But so read file. That's the output we had before. Spilt means that we're adding it, right? So that means that we're adding it to our per desk cache. Interesting. Sorry, let me do this again just to make sure that I understand what these hashes correspond to. Okay, that makes more sense. So I don't know what happened there exactly. Maybe because I did 4 twice in a row. There might be something unusual there. It's not the bug we're looking for. So we're going to look at this one. So we're freeing the old one, creating the new one. So then we read that file, we add it to our per desk cache. Then we run goad. Goad says, well, okay, it has this bill and that rain, so those are the ones that should be running. That's not live, so we're not even doing anything, and it prints out a bunch of this stuff. But these are all start with goad, right? None of them actually hit forward really at all. That's not going to be the case here. So I'll do this with number 6, and we'll see what we get. So that starts out the same, or close enough. And then we get to goad. Goad does everything normal. It's, again, a little shorter because we only have kids and base here. Kids is not live, so it's only base. Base has a bill of this and rain of that. So these are the apps we need to start. So we're like, okay, make file app acme. Make file. So the fact that we got to make file means we missed the per desk cache. That's wrong already. We should not be missing the per desk cache. And then just make sure we understand the rest of this output. So then we check, okay, what about the per desk cache for ASN1? And we apparently go ahead and actually create it, right? So we miss, so forward cache file. So we create that. And to do that, so we're caching this based on the dependency of this specific veil. So remember, file is the kind of thing we're mostly looking at, and they generally depend on validating the contents of that file, and that's the one that's going to have the lobe. So we're bumping that to reference 2. So something else already had a reference to that, okay, and then we add that to our per desk cache. Okay, so then we do the same thing for library and so on. Okay, so what it looks like to me is we have lost the per desk cache for app acme. We've also lost it for its structure file for ASN1. We've also lost it for this library. We've also lost it for all these. And that shouldn't be happening. We just shouldn't be losing that. So next steps, there's a couple of steps we could take. We want to basically find out, is it lost, or is it was it errantly deleted, or is it like at a different key or something that we're missing it? And we can do that potentially by printing out aspects of the cache. To understand what exactly we should be printing out, we're going to want to read that code. So we want to understand what is supposed to delete that and what is supposed to, let's see. Another question is, are we actually hitting it in the global cache? It looks to me like yes, we are hitting at least the veil in the global cache. Yeah, bumping to ref2. In fact, we appear to be hitting the whole thing in the global cache, right? So bumping to ref2, let me make sure I understand what bumping to ref2 refers to. Bumping to this, yes. So this means that no, that means that we missed the global cache. Bumping is only here. Yeah, so when we see bumping to ref, let's see, so cache creating, or it's this, right? Yeah. So cache creating means we miss the global cache. Okay. So we didn't just miss the local cache, we also missed the global cache. Now, it's possible, right? So in particular, we missed it for building this file. We did not miss it for validating that file. Now, it's possible that's, well, I don't know. Yeah, it's possible something else refers to it. But yeah, so for some reason, we missed it for building the file, not for validating the file. Now, if it got removed from the global cache, remember that the global cache and the local cache are supposed to be connected by this ref counting scheme, so that if you remove it from all of your local caches, or sorry, all of your per desk caches, then your global cache should also remove it. So it's possible the issue is still that it got incorrectly removed from the local cache. Okay. Let's scan through this, see if anything else looks suspicious. Nothing looks that. So this is, yeah, once I let it run all the way through, it looks like this. We see creating. We don't see a lot of like freeing or anything. Yeah, the only thing we freed was here, which is freeing the correct thing, right? We have an algorithm that says, okay, basically look for all the things that potentially ought to be freed and free them. And it seems to have correctly identified this is the only thing that changed, and nothing depends on it. And so we might as well. And so that's the only thing that needs to be freed. So the question is, why didn't our per desk cache persist? Or are we just looking things up incorrectly in that or something like that? So we go to Park, which is that's where you execute a commit. And we need to find the stuff related to like spill and sprig. So like here, for example, so lose leaks is the thing that's supposed to promote the cache. Lose leaks takes a verbosity level. It takes the global cache, and it takes a set of caches that we cache keys that are invalid now. So we should actually look more closely at the arguments to that. So that set of cache keys is so that comes out of promote forward, basically. We take the difference in. Okay, so we should look at promote forward. Promote forward takes flu, which is the per desk cache, and the set of files that changed, and it goes through and produces a new one of these. So it's throwing away everything that needs to be thrown away from our current one without regard to reference counting. And then lose leak takes in that takes in a list of all the things you threw away, which we find by just doing a set difference, and prints out, for example, this line that we've been seeing, and says, okay, I need to throw that away. And so there's a couple things that can happen, right? Either when you throw it away from a local desk, you're going to be in one of two cases. Either you were the last reference, in which case you're going to free it, and that's the one that we saw down there, or you were not the last reference, in which case you just decrement the ref count. The only other case that we have here is if it's not in your global cache somehow, then we just print that it wasn't in your global cache. I guess it's fine that it's gone now because that never really should happen. But if your global cache was cleared somehow without your local caches being cleared, then that would happen, and it shouldn't break anything. We haven't been seeing that printf though. Okay, so that's supposed to be. So that's lose leaks plural, just does that for all the leaks that were given. And so promote forward is the one that's supposed to recognize what gets thrown away. Now, we're not seeing, so what was the other term it had? Decrementing, right? Yeah. We're not seeing decrement happening anywhere either. And so that means that these cache misses are either not getting interpreted that way by lose leak, or they are they're not even getting, like, they're not even missing at all. They're just or like the cache entries are maybe even still there. They're just missing for whatever reason. Okay. So what we want to know is, make file app acme. Why did it not find something there? So what can we print out? Can we print out a leak? Not really. Sorry. Can we print out our flu is what I want to print out. I believe you can print out leaks, right? Yes, because it's just pores. You cannot print out your whole cache because the soak is the response, and that's got a bunch of bases and stuff. But we can print out everything except for that. And so we should probably do that. So let's see. So make file, this one. This is where we want to say, let's see, do I have I feel like I might have like a print flu or something. Maybe not. It's not too bad to write something. Okay, so if we got this far, then we want to print out our per desk cache. So that's going to be spill is spill dot nub. We have a nub here, right? Yeah. Spill.nub, and sprig is run by sprig.nub head, right? Basically, we want to say print out a map of missed a leak is good, but not the soaks. So that should work. And we will set up a watch thing. So this is watch. This, except it's neck. Get that going. Unfortunately, we're going to run into the same, like it's going to take an extra minute for this thing to even compile, or to even finish, because of the bug that we're working on. But that's okay. You can probably skip forward a minute. I'll probably not have said anything interesting. But while it is compiling, we should think about what else. Wait, what happened there? Oh, we started printing everything out. Oh, actually, yeah. Even this case of it is worth looking at. Although here we do actually expect it to miss all the caches. But you can see, first of all, that this isn't huge. It's big, but it's certainly acceptable. So actually, yeah, it's not going to take an extra minute. It's going to take the normal time that it would take, because it's doing this from an empty cache. So it's the normal time that it would take to build all this stuff, which is still a while. Maybe a little extra time because we're printing out some relatively large stuff. But this is the kind of output you should have while you're debugging. Is you should be able to look at this and be like, oh yes, I can see everything it's doing. I can see what my cache looks like, right? For example, this entry here is, we say libnaive. Validating that is pretty straightforward, right? It has no dependencies. So validating it as a missed, as a request, says that the global, the global reference to it, the reference in the global cache is this, which is that we want to validate libnaive at this lobe, and we have no dependencies. Something like file libnaive transactions, though, it's that's the per desk cache entry for it. Sorry, per desk cache key for it. and the global entry is at this, which is that, yeah, we want to do this file, but that depends on libnaive. So this other file, it also depends on validating that libnaive itself. Sorry, it depends on these three things, right? It depends on libnaive, it depends on libethereum, and it depends on validating libnaive transactions itself, that it has the same lobe. But each of these also has their own dependencies. This doesn't have any dependencies. It's a leaf. Veil is always a leaf. File, though, is not. So file of libnaive, well, libnaive itself depends on validating libnaive is correct, and it depends on libtiny. Libtiny depends on validating libtiny has a correct lobe. Libethereum is similar. It depends on validating that libethereum has the correct lobe. If all of those are correct, then you should hit your global cache. So that's how we read that. Okay, this finished compiling. Now, let's run our example. I like to type something so that I can search up for break to find the top of this if the output's going to be large. Okay, so now we do this at number 7, and we start to see what the output is. Like this, right? Search for that. Okay, that's where we were. And so we say, okay, we got all the way to make file app acme. That's where we were. And we want to say, okay, what was our cache at this point? Probably should have printed out what exactly we're looking up, but our cache certainly has stuff, right? It's not that we threw away our whole local cache or something. There's the spill here, and there's also the sprig down here. So the spill is the list of roots we have, and the sprig is the map of those roots to their global cache key, and also the data. But we are not printing out the data because it's too big. So acme, we can just search for acme here, see what we find, and the answer is nothing. So acme is actually just not in our cache at this point, because you'd expect to see, like, if there was something in there, it'd be like, is there anything related to, I don't know, hood in here? Yeah, well, there's this, right? These paths show up in here. So the fact that acme didn't show up in here, and in fact app hood also is not showing up in here, I think, right? We have gen hood, but that's it. Do we have app anything in here? Was it that? Yeah. No. Now we have it, right? After we load it in there and we create it, then we do in fact go, let's see, cache read file spilt app acme. Right, so we're saying spilt means we're adding it to our PRDS cache. And then if you just scroll down a little bit, you see, when we're working on the next thing, we print out our whole cache again, and we see, oh yes, Veil app acme is here at a particular lobe. And so you see it in both the spill and the sprig. It's strange to me that it's just the veil, though, not the whole file. Shouldn't it be the whole file in there? Let's see if that shows up anywhere later down. Yeah, shouldn't the whole file be in there? So veil, is validating the file that it's the correct lobe. File refers to, I know it's a really generic word, but it means you compiled it. You compiled the Hoon file into a vase. And we should have those in our PRDS cache. Maybe that only happens later because all of these things are part of acme. That might be the case. Let me search back up for that. Yeah. Okay, so the answer there is we were we were still in the middle of compiling acme, right? So we had gotten as far as validating that the text of acme, not even validating, but creating a veil entry, right? Saying that the text of Acme has this lobe, has this hash. Not that one. It's this one down here somewhere. But to compile Acme, you still need all these other things, right? You still need to have processed verb and Jose and PKCS and all these other things. And so we were still working on those dependencies. So the reason why we didn't have an entry for app Acme at that point is because we hadn't finished compiling it. We were still in, we were compiling those other things for the purpose of being able to compile Acme. Once we did that, we added a file in. So now at this point, app Acme, it looks like we do have a file entry for it. So everything looks fine. So the question is, why is it that the next time we run this, app Acme is not there? Right? Because it's here and it's also, wait, going up. Yeah, it's also here and here and here and here. It's coming along for the ride just fine. So how did it, let's find actually where it does come in. Actually, I think this might have been longer when I scroll back. Yeah. 40, for 50,000 lines is not enough apparently. Okay. Okay, so what does that tell us? That tells us that yeah, for some reason that file is not in our local one. Is it in the global one at that point? No, presumably because we missed it. No, we don't know that we missed it. Although we know it later on, right? Okay, what do we know about the global one? Because by the time we get to gain leak, to know whether it's, we would have to see adding and giving, and we haven't seen that at all for them. Bumping. Bumping means that your dependency was in there already. It doesn't mean that you yourself were in there. So we believe that we're also not in that top level one. Okay, so what do we want to know? We want to know app Acme. When does it stop existing in the global cache, and when does it stop existing in the local cache? Because see, promote forward like that goes to lose leak, right? And lose leak is always going to print something out. So promote forward shouldn't be the one that's removing it. So what we're gonna have to do is start checking things, right? Because we're in danger of thinking too much about what could possibly change this. What we want to check is very specific. We want to look for app Acme at various times. So let's first neuter this printf because it's too big. We really just want to know, like, is it there? But the fact that we got to make file says it's not there. So let's comment this out altogether. And we want to look up that missed in park at least. Let's see, promote forward, or the call site for that is here. Okay, so what is this? I'm gonna look up what is it? Sprig dot nub. So Copilot doesn't know what it's talking about right now. I'm gonna turn it off. Let's see. Spill.oldfod and spill.fod. Okay, so, or fod.dom. Yeah. Sprig.oldfod fileless. The path is app acme hoon. We don't think someone threw in an errant trim somewhere, do you? If this is getting trimmed from time to time, well, I forget. Actually, no, we removed that from trim, right? Like, so trim inside of stir throws away these caches, but regular trim does not. Yeah, regular trim is back to a no op because throwing away the caches is kind of not that helpful usually. Okay. Okay, so that checks whether it's there. And then we want to do this again after promoting, where we want to say, just for convenient, like visually being able to see them both at the same time, I'm actually going to do this, the same check as before, which should, it should show up the same, but we do sprig.fog.dom afterwards. Okay. And then after lose leaks, we'll do it again. Okay. I'm going to start compiling that while I think about more printfs to add in. Let's see. Okay, well, what more printfs could we do? Because we definitely don't know that this is where it's getting lost. We could check the beginning and end of Goad. Yeah. This one, yeah. Like, cause like build agents is supposed to do it, but we'll do this here. We don't have. Let's see. We have a DOM though, right? We have to do that within the context of each desk. So here we have a den. Yeah, I think we can do it here, right? And then we can also do it at the end. What does the end mean? So this is saying yeah, if we needed to build something. Oh no, this isn't actually building anything yet. This is coming up with our list. Okay, we'll leave one in here, and then we go to build agents. This is confusing. We build these separately, right? We have a okay. Right, so we get to here. Within each desk. So this is per desk, this is per agent. Per desk is here, right? So okay, so we want to print it here. And it's sprig.f. No, .fod.f. I think. Something like that. Okay, that would at least give us something. First of all, let me check. Now we have this printf. what did we add? So we had, am I doing get by? Oh, I meant to do has by, but get by is fine. So park 1, 2, 3. Okay, so so even park 1 has nothing immediately. So what I want to know then is, yeah, after goad, basically after goad, is it there? So the other one we want to do is here, after we've loaded all the apps. Now is it there? Right, because by the time we start park, but it seems I can put this at the top of park as well. Yeah, so but by the time we start park at all, if that goes through, let me actually do that to make sure. It's already gone. The end of park, we wouldn't expect to see it because Go doesn't have, well, does Go get called from park? It might actually. Yeah, it gets called here. So here we would expect, so it should be parks 0 or park 0. And then here, park 10. But that's not that anymore, right? Which is what that error down there is saying. Sprig.fod.dom, and here we want sprig.fod.dom. It's that, right? Make sure, because my copy thing only happens every 2 seconds, so if you switch quickly, you may not catch it. So sometimes I'll kill and restart those. Okay. Let's see then. What else are we potentially going to want to print out, or you can also just look more thoroughly at the goad process thing. Wait. Okay, FOD is. Okay, so Ford has in it a flu directly, so it's just sprig.f, right? I think that's correct. We have tizkets of, yeah, nub.f. Nub.f. Is it sprig.nub.f? Yeah, actually, I think it is. Let's see if it errors like that. No, apparently not. I think it is, though. Like, it can change throughout the middle, so it doesn't. Sprig comes as an argument, and that's apparently enough in the result of this that you can read out the argument, but you don't actually want to read out the argument. You want to read out it's the part that's in the state. Yeah, okay, I'm actually just going to kill that and commit again. Okay, what's FOD? FOD is just a flu directly. So if you have, so FOD.dom makes sense. Okay. Oops. So make sure let me just review these, make sure these are right. Park0, sprig.fod.dom, that seems correct. Sprig.oldfod and sprig.fod.dom, that seems again correct. Sprig.fod.dom, .den, sprig.nub.f, yeah. The results of f, where are those supposed to go, right? Because f, you need to somehow extract that into your just overall state. Should be like in a bet or something, or I guess here we produce nub.f, which goes into wrap. So wrap is supposed to save the forward cache. Now, if I remember right, it only sometimes saves the forward cache. It only saves it if our like if it's for the present, basically. So taco flow. Produce forward cache appropriate for the Eon. It's not even produce, it's save this if it's, oh no, it does produce it. Okay, well, the compilation finished. So let's try our test. Okay, so it's not here, not here. Code one, build agents. And we're doing goads. Yeah, so build agents, we're doing, yeah, there should just be one of those per desk. We only have one desk, so it'll be, at the end of this, we would expect to see it there. And if we don't, that means like maybe wrap is working incorrectly. If we do see it, then that means something after this has failed to save the result or has deleted it for some other reason. Bumping to ref 1. Isn't that weird? Bumping to ref 1 from ref 0, but we're not creating? Or maybe it is after creating. Yeah, so like bumping to ref 1. Here, it's right after creating. What about here, though? Lib pprint. Here we created bumping to ref 1. Okay. Print. But so we're saying dojo to pprint bumping to ref 1 because we started doing, so we started doing app dojo and we're like, okay, well, dojo depends on pprint, so bump that. But bumping to ref 1 is weird because we created it here. It should have gotten a reference from whoever included pprint. This is all coming from when we compiled pprint from libsol, sirlens, sirsol, app dojo. So it's all coming from app dojo. Why are we back at app dojo down here then? Oh, it's saying, so this is all kicked off because of App Dojo. And so it's building all this stuff. And then once it's done building it, then it's adding it to the global cache. And that says, okay, now we want to bump our dependencies. So anything here that's bumped to ref1 just means that we're the reason that it just got built. Okay, that seems fine. So let's see. Do any of these printfs? Let's see, build agents 1. No. Did I mess up the get by part? Map of mist. Mist would be file and path. Okay, where was it that we had that too long of a printf? But we did see it there eventually, right? So this one. Let's throw one of these in here. Because, like, I know we visually saw it, but you have to check that your printfs are working. Build dependency. Nub is just here. We're gonna do file plus app acme hoon. And we want it to have some priority. And that should get called many times. And the first time it should show that it's not there, and the later one should show that it is there. What else do we want? Oh, right. We also, because we don't know the wrap is working correctly, we should put this in here. Let me actually do that one. Oh, I think I killed it at a time that. Whatever. Okay. Yeah, so if that, like, so, right, so there's a few theories. At every step of this, we're trying to get rid of a theory. The theory here is, or really, ideally cut the number of theories in half or something close to it. The theory here, because build agents 2 says it's not there. So the theory that we're testing with this printf is that maybe we're not even looking up the right thing somehow. And we're just confused about how this printf works. The one we're testing here is maybe it isn't there to start. It gets put in there, but it doesn't get saved somehow. Right? Maybe this wrap is failing. And if that's the case, then that narrows the problem down a ton. And if that's not the case, then that means that the problem is sort of before here. That maybe going from one file to the next, like that tizcat's maybe not working right. I mean, it's supposed to be working right, but who knows? Or maybe it's not getting saved or output at the result of build dependency. I don't remember any of this stuff changing. So that's all very strange. But that's part of why I feel like this whole direction may be incorrect or like a lot of things that I feel like I just learned maybe are incorrect if this is incorrect, right? So like, I mean, it looks like, right, that's what we're looking at, right? File path app acme. This is not the go through we really want to do, because this is the one that's starting with an empty cache, but it's maybe instructive to see, like, yeah, serve verb depends on veil verb, and so we create it, and we also bump that reference to 1. Here we create bump to 1, create bump to 1. App Acme, we create like here's all of our dependencies for App Acme, because we just built all of these for Acme, Jose and PKS or PKCS and so on. And so once we've done that, then we're like, okay, now we're going to create an entry, and that's going to give us and it has all those dependencies. So let's see what comes after this. Oh wait, I think it may have found it, and the problem is I did get by, which what I wanted to do was just has by, because the problem with get by is it's going to give a soak, and a soak is a vase, and a vase is probably too big to print. Yeah, we should. Okay, so all of these. Okay. Wait. Here, yeah. Okay. Let's try that again. That, I mean, we'll verify as this comes through, but what that really suggests is that our printfs are working correctly. That is how you should be looking things up. Which, if that's the case, then the fact that it's not there at the end of code is potentially a really good thing. Or even at the end of build agents, because that means that our problem exists in here, and that is a small area of code. Make sure I understand what wrap is supposed to do. So wrap is supposed to save the forward cache. It does that by, what does it do? It takes in a ship, a desk, and a possible eon. We're giving null for that eon. A result and a state. And so this is supposed to be producing the result, which is load gall, and then the state. And it basically is supposed to save that state if the eon matches reasonably. And so the way that it saves that state is it says, okay, call den, call taco flow of either the most recent commit or the given commit. m2.state, which is the local cache. Okay, so taco, and then that goes into rough. What? Okay, so build agents. Where is build agents in? This is in that loo desk or something, right? Yeah. Okay, so we're calling wrap in here. Modifying rough as we go, but we're not. Right. I was like, we're not producing rough. We're producing emil, which produces our current state. Rough is in our state, so that should be in the result of emil. Okay, this finished. Let's get some information. Look at that. That's almost certainly our problem. I would like to verify. Well, okay. First, I'm going to do this, make sure that shows up the same. But I would like to verify that printf works differently over here. is, I think it's this one, right? So the idea is this is build agents 3 and this is build agents 2. See if that works. Okay, what that, because here what we're seeing is, yeah, build dependency. The first call to build dependency says, no, we don't know about Acme. And that itself builds some of its own, well, dependencies. And those still don't know about Acme until we finally finish Acme. And we're like, okay, now we can create it as a cache entry. Here's our dependencies. And then it's like, yeah, of course we know these. They're just right here. And so there's no problem. Okay, so then the question is, right, sorry, so then that's like, yeah, of course we know it. We know it. All of build agents 3, of course we know it. But build agents 2, we're like, I don't know what you're talking about. So F, oh, because it doesn't get saved to F there. Right. Okay, we actually shouldn't see it there. We should see it in, let's see. Because wrap is supposed to have saved it elsewhere. It's supposed to have saved it in, because it's misleading to have F here. F is in here, really. In fact, it's in here. We shouldn't be able to refer to F out here. What do we have? We can call forward again with our desk.i.sat. And no, wait, what are the arguments here? So it's got to be a different reference to forward. Yeah, this one. So it's this where we say look it up in there. Yeah. Okay, so we want to make a new F here. Do it inside the printf. See if it's in our state now. Okay, let's try that. Yeah, because this definitely shows the it's gone. This definitely shows the same pattern there. But yeah, it's because F doesn't get updated through there. So we're actually dang, I did this in the wrong clay file. I think that's the one that's over there. Okay, where are we at? So this should look like this, and this should go in here. Yeah. Okay, so that may have just been a mistake of printfs there. We'll see. Yeah, it's two totally different answers depending on if it's there at the end of Goat or not, or at the end of build agents, I guess, or at the end of this desk for building agents, right? Lad, what is lad? Lad is load gall. What is load gall? It's the loadout for the result of Goat, basically. Okay. Do we have any printf after Goat? I feel like we did, right? Yeah, that one. The Park 10 one. Do we have a Park 10 up somewhere? Yeah, so Park 10 says no. That's interesting. Wait, okay, sprig.nub.f. Oh, right. I actually have to put this here because we refer to f up there. I'll call this G. Do that. Make sure those are actually separate. But okay, if it's not in Park 10, okay, we should look at what's happening in Park 10. Check for that in, yeah, that. Because we goading ourselves, or is someone else goading for us? In this case, we are goading ourselves, I believe. Are there any other references to Park 10? Not really. Yeah, I mean, we just went through the whole goad process and then we hit Park 10. Okay, so that means... Right, okay, so how did it not get here? Goad is supposed to update Park. So goad, there's a couple of functions called goad. This is the one that actually does goad. This is the one that's supposed to sort of step out of body, run goad, come back. It's possible we messed up that. But again, has any of this stuff changed? I don't know. I don't know what's changed. So what's supposed to happen is we run a bet. That gives us a new global state. We run goad. And then we get going again and reload in the moves that we had from before. Let's see. Okay, so Park 10. We wouldn't expect it before we goad, but we just goaded right there. And so now it should be there. That suggests inner goad one of because Dom is still like we didn't shadow Dom or something, right? It's still the one that's just like at our top level. Wait, where was I? Yeah. So is that dot park? Yeah. And here we have access to that. And then we're back. And we should still have access to it. Yeah, because this... Oh, interesting. So build agents 2 still says... I should have renumbered it so that I was for sure that it's something different. But it still says that it's not there. So maybe it is wrapped that's the problem. Okay, let me try committing this while I take a look at that. Okay, so build agents 3 has it. Build agents 2 does not. And we're getting that from calling Ford, which says taco Ford of We get that desk. Then we do hit dot dom. Yeah. Right. So use the top. That should just get our current forward cache. This taco forward is get the forward appropriate of a particular taco, which says get sort of the right stuff, and if the taco matches the top level, then give our actual forward cache. I can check this more specifically because this forward is pretty it's pretty roundabout, when what we should be looking for is, once we have this den, we can do dom.den, right? We can do fod.dom.den. Right, so we can just do this. Our desk.i.set, and then it's sprig.fod.dom.den. And I'll bump this to make sure that, yeah, because this is definitely saying, as far as that other thing goes, like it didn't get saved. Okay. So that didn't get saved. I'm going to keep verifying that it's definitely not there. But the evidence is starting to suggest that it didn't get saved for some reason. So nub.f is going in the wrap. Wrap is here. It takes a ship. That's our ship. A desk. That's our desk. An eon, or null, we send it null. A result, which is sig. Because, whoa, okay, sorry, I've confused myself. This is actually head recursive, or yes. Here it's tail recursive. We accumulate in lad. Here it's head recursive. We get a lid and we cons onto that lid as we go. So the okay, but nub.f is still gets updated before we do that. Right, so nub.f gets updated here. So that's why when you get to the bottom, that is the end. But on our way out, as we're popping our way out, nub.f shouldn't be changing. We should just be consing a bunch of stuff on the front. Okay. And so then here, we should be getting nub.f here. So nub.f state forward fusion. It should be taking cache and pam2.state. So cache is global forward, pam2.state is the local one, and that should be going to taco flow. Yeah, these printouts are pretty convincingly saying it's just not there. Okay, so do now you say it's not there. Now I want to know, is it empty there? So, okay, build agents 23. That I want to now just say just print out the whole run by Sprig head. Is that just like empty, or does it have other stuff in it? Just not us. Yeah. Okay. So then, what were we saying? We were saying wrap takes this stuff in, it passes it into taco flow in the context of, let's see, so basically we inflate that desk. We call taco flow with that, and then that gives us something that we then save in rough, which is just in our context here. And then like it's part of this core state. And we produce res and we produce ml moves, which closes over, or how do you want to say that, rough. Okay. So we should be doing, let that DOM of that, go into taco flow. Taco flow is inside of the desk context. And that's supposed to be producing the res, which it does. It also looks up and says, if this is a local desk, that's the what is sig ref, and a taco of let.dom. So the hash that we're at the top of is the same as that. It's a bit, the flow here is confusing because we go from null, meaning definitely save this, to a hash, and to a version number. Taco flow, yon, let.dom, or u.yon. So taco flow, first argument we're giving here is an eon. But this expects it to be a taco. What? How did that ever work? What? It shouldn't save it because this argument, first argument to taco flow, is an eon, right? It's either the eon that's passed in, or in this case, it's let.dom. Okay, so let.dom, it's like, 16 here, right? I look at that printf in a second. And so we go to taco flow and we're like, okay, well, what's in taco flow? Produce forward cache appropriate for the eon. Okay, sure. What do we have in here? Well, it's simply we check and see, is eon to taco of let.dom equal to that thing that we passed in as an eon? And like the answer is going to be no. So we're not going to be saving this forward cache. So Go doesn't save its forward cache essentially. Now, how did we get this far without? Is it? You don't think it's because the cache just wasn't getting cleared? No. Okay, txt had to give up. Yeah, okay, so it appears that Go simply doesn't save its forward cache. And okay, so somewhere here we printed out, right? The idea was to check and see from here, are we sure that Acme is not in there? This is way up at the top of the file, right? Okay, so yeah, so Acme is definitely not in there at that point. There are various things in there, but Acme's not, because Acme came from Goad. So it's as though maybe before somehow Go. Yeah. Okay. So we see a bug. It appears to be the bug. My guess is if I fix this bug, this will solve the problem. I definitely want to know why this wasn't a problem before. Let me see if anything, the taco flow looks different here. Well, we don't have a taco flow, so that could be it. What? Wait, there was a change somewhere. Okay, what's wrap here? Wrap here is Aeon flow. Oh, Aeon flow here. Okay, when did that change? That'll 100% do it. Okay, I think we got it. Let's. Now we gotta fire up git blame and find out where that changed. I have a vague memory of this happening. We switched in some places to use fewer Aeons and more tacos, and here it's the combination of like insufficient auras, and also it doesn't even matter because the whole thing is wet anyways, meant that we didn't find this. Okay, so clay, Aeon flow. Sorry, it's taco flow nowadays. So it's this. Blame on that to find the PR. I think it's like 50-50 that I wrote this code. And if I didn't, I probably told the person to write this code. So let's see. Taco flow. Wait, I need to go through this one. Search taco flow. This. Oh, it's in remote scribe protocol. Okay. Yeah, from forever ago. I'm like, I remember this change happening, but I thought this change landed a long time ago. It did not land a long time ago. Okay. Okay. Okay, so make sure that I understand what happened here. So at some point, we basically realized it'd be convenient to be able to read some stuff by taco, which is the commit hash, or sorry, by commit hash rather than indirecting everything through eons, through commit numbers, because sometimes over the network you actually just want to refer to it by hash, don't want to refer to it by number. It's more convenient. So we refactored a few things that way. So this commit from May of last year, just about a year ago, a couple weeks short of a year ago, changed Eon forward to that, which is all very reasonable. Change Eon forward to taco forward, and when you do that, you want to say, instead of being passed in an Eon, we're passing a taco. So how do you lift that to that? Well, you instead of checking let.dom, you check Eon to taco of let.dom and check whether that's the taco that's passed in. The problem is that taco forward is called in multiple places. Actually, wait. This predates. Is this just a good old fashioned merge conflict? I think so. Because the other thing to check is the call site to taco forward. There's a bunch of calls internally to taco forward. And then there's probably the last one in the file, I imagine. Here. Because Goad is more recent, right? Goad is only a few months old. Or I guess, wait, Goad is 9 months old now? Yeah, but it didn't get released until, I don't think it got, yeah, that didn't get released until the end of the year. But I added that code in July. So that's the timeline, right? In May, you have unreleased code that changes taco flow to eon flow. In July, I add another call site for taco flow. Sorry, for eon flow. The and then now, in April of the following year, sorry. So my code gets released in December of that year, 5-6 months later almost. And then 4 months after that, in April, right now, you have that original code that switched it from eon flow to taco forward gets merged. Actually, so that was 1 month ago from now. It doesn't quite compile. It gets close. Ted realizes, yes, taco forward is, or eon flow turned into taco flow, and so he changes them, and well, it's some combination of Ted and Wikram are doing this merge conflict resolution, this really long merge conflict resolution. I'm sure that was a lot of work, a lot of things to just be following check, and miss that the argument to taco flow needs to be slightly different. In particular, instead of yon led.dom den, it needs to be turned that into a taco. Wow. Okay. So that took a while. Let's see, how long did it take? It took 1 hour and 42 minutes from going from where we had a reproduction of it to finding the problem, finding exactly what caused the problem. You haven't actually, though, we can't stop the clock yet, because you haven't actually proved that was the problem until you actually change it. That's another pet peeve I have of people who debug until they find a bug, and then they're like, there's a bug, therefore I fixed the bug. And it's like, well, no, English has articles, a distinction in its articles for a reason. Okay. So let's test out our theory, which is that we want aeon to taco, which I don't know that we have access to. It's that. Where is Z? Z is utility functions, but it's inside one of these things, which we don't technically have. Okay. Eon to taco, though, is just... All right, I guess we have access to it, right? Yeah. So it's aeon to taco from Z of this. Okay. Let's see how that works. The other thing that this says, by the way, is that the local cache, like the desk specific cache, matters a lot. Because even just going through and parsing these things is potentially a lot. And actually, it wasn't just that it wasn't getting saved from each at the end of Goad. It wasn't getting saved at the end of each desk either. So on a ship that has a bunch of desks, this problem gets much, much worse, because each one... Well, and actually, it doesn't matter, because it's only the... Is it only the... Actually, the global cache is probably not getting saved either. Yeah, that's why we're missing a bunch of global cache ones too. So forget what I just said. We're missing a lot of global caching. We're missing a lot of local desk caching. Forward is slow if you don't have any caching. I don't know that we're quite at no caching, but we're pretty close. We might be at no caching if you're with this bug. No, it's not no caching. No caching that is triggered by Goad. But still. Okay. Let's see if that works. philosophize a little bit and bring it back to the like, how was this as a debugging experience? Could have been better, could have been worse, right? What I appreciate about the way that we did this here is that I didn't remember any changes to Clay, really. At some point, I would have remembered Remote Scry, but Remote Scry, most of those changes, I think of as related to foreign stuff. I'm like, what did Remote Scry change about local commits? It should have changed nothing. And the answer is, well, yeah, but there was this one little refactor that we made a year ago that I remember us making, but also that was like a year ago. And let's see. So now, let's see if this works. No, it's still doing it. And a taco. Oh wait, I changed it. I've confused myself as to which Clay file is which. Here, we need, first of all, get rid of that. But also, sorry, like I was editing this file, like the Zot, not the neck. So this needs to be here. Sorry, this needs, see, for that to compile, it needs to go like this, right? Yeah. Okay. Right, so reflecting. It's a huge diff. You're not going to find that by looking through diffs. You might be able to, I don't know, it wouldn't be a terrible idea to spend a few minutes looking at the diff to be like, are there areas of this that I didn't expect to change? But it's notable that, let's see, zden. But it's notable that I didn't have to, right? I didn't have to know any of that. I didn't have to know at all what changed. All I had to know is, more or less how this stuff works. And half of that I'd forgotten anyways. And so I just had to run through in my mind, okay, what is this supposed to be doing at each step? What should I expect to see? And then at some, and then start printing things out until you find something that looks weird, right? Once once the whole thing's taking a minute, okay, that's something weird. How can I turn a behavior that's weird into a printf that's weird? And the answer for that is, well, it looks like it's missing a cache. Can you print out that it is missing that cache? Print out the whole cache. And once you do that, then now you're hot on its tail, because you're like, okay, actually that same printf showed both that it wasn't in the cache, and then afterwards it was. And so we'd expect it to stay there. That reduces the scope of your problem a ton, because you're like, hey, it's just that there's this noun that should be this other noun at this time, and it's not. And then you just see, okay, what was the evolution of this? Sprinkle in some printfs of, okay, when did it change? When did it? Because at some point it was correct, and at another point it was wrong. When did it change? And it turned out the answer was in build agents, between here and here. When I didn't have this printf, I still knew that the answer was between here and, like, that here it was wrong, but it was correct inside of build file. So I'm like, okay, it's correct while you're going through this loop, but now by the time it gets out here, like, once you're there, you just narrow it down to, we ended up having to narrow it down really far, right? We narrowed it down all the way down to wrap, which is a 4-line function. And then taco flow, which is a 5-line function. And like, basically we knew it was in there, and you can narrow it down further, right? The next step would have been print out like something in each of these branches, right? Check and see if this condition is correct or not. And if that would reduce the problem to just a few lines. And then once we realized, oh, actually, we're not hitting this branch, then it'd be like, okay, print out each of these things. Print out and a taco. So print out let.dom, print out and a taco of let.dom, and print out tac. And what we would see very quickly is and a taco of let.dom is this big long hash, and tac is like 16. And we'd be like, oh, okay, tac is not a taco. Once you're within, 5 or 10 lines of the bug, there's a decent chance that you'll find it on its own. Look at all those send.ys. So now, forget if we did 10 already, but look at that. Look how fast that is. Problem solved. Crisis averted. Yeah. Okay, so that's the flow to debug this stuff. You don't have to look at any diffs. You don't have to look at anything else. If you have a bug, a reliable reproduction of a bug, find a point where it's good, find a point where it's bad, print halfway through. That tells you which half the bug is on. Do that over and over, and you'll find exactly where it is. All right. Now we're at what is it? 1 hour and 52 minutes. I think that's a more honest time. All right. I'll see y'all around.